This problem is a coefficient of variation problem. This is another method of being able to compare data from different populations. And it uses some of the same components as a z-score, but in this case we don't have a sample data point to work from. We're just given the historic long-range mu and sigma in this case. So the median, the mean and standard deviation. And we're given the results here. We conducted a study of the variable interest of the number of hours of overtime. The variable of interest, is the number of hours of overtime scheduled per week at each of these divisions, okay? So the mean number of hours at Division A is 300 with a standard deviation of 50, and so on for B and C as the data are laid out here in the table. In the table right here. This is our coefficient of variation measure here, and so we take sigma over mu and multiply by 100. And so we, if we were to do that, or when you're given these data points, then you would then calculate these, and the question is, based upon these data, which division has the greatest relative variability? Justify your answer by computing the appropriate measure. Okay, so we've already talked. The appropriate measure here when you're given these kinds of inputs is going to be the coefficient of variation, so you can compare them. It would be very difficult to compare these just based on number of hours of overtime worked, depending, for example, on how many employees were working in each division, perhaps a seasonal element of it, and so on. So you can't just take the hours at face value and say Division A has the the most variable overtime hours or something like that, because you don't have all of the information there. And so if you use the mean and standard deviation, you can use that to help get a comparable number. All right. So let's put these into the formula then. So A is going to be 50 over 300 times 100. B is going to be 55 over 170 times 100. And C is going to be 38 over 125 times 100. That's C. Okay, and so A is going to be 16.67 when we calculate this out, and B is going to be 32.5, and C is going to be 30.4. Okay, so the greatest relative variability. Okay, and so when you look at that, right, we're looking at kind of a comparison between how big is the standard deviation relative to that mean. This is our largest value here, the largest coefficient of variation. So plant B is has the greatest relative variability. Based on the coefficient of variation. So that, when you look back at the question, justify your answer. The justification is that we're basing it on the coefficient of variation. So there is some calculation involved, not just some intuition or I'm guessing or what have you. So we're saying based on this calculation, we're comparing the relative variability relative to each other, that is, to each of these plants, and their typical results, mu and sigma. We come up with plant, or division B, has the greatest relative variability.